Welcome to today's deep dive. You know, centuries ago, people used to call thorny hawthorns the cradle of the forest.
Right, because they were these fierce protectors for vulnerable young plants.
Exactly, keeping them safe from roaming cattle. But then naval empires needed perfect, straight timber for their warships, and that whole natural system was largely wiped out.
Yeah, and today, I mean, the main threat to nature isn't roaming cattle anyway. It's concrete, urban sprawl.
So true. So how do you build a protective forest in a space the size of a tennis court? Today we're following Kesser and Steen, two students who actually got the secret recipe from this mysterious man in the green shirt.
Yeah, he's the expert at the nursery right behind their local garden center. And they're trying to build what's called a Miyawaki forest.
Right, which needs a super specific mix of native plants.
Exactly. So they're asking him for advice on propagating their cuttings and seeds, because we're talking about an incredibly small urban footprint here.
Seriously tiny. Their plot is literally a 26 by 36 meter patch of dirt.
Right, just sitting directly next to some local tennis courts.
Okay, so to fill that tiny space, the man in the green shirt tells them they need three vital layers. You've got your canopy trees, like oak and ash.
Mm-hmm. And then the understory shrubs, like hazel and our old friend the hawthorn.
The cradle.
Wait.
And finally, a ground cover of wild strawberries and ferns. But wait, let's unpack this for a second.
Sure.
If you cram, almost 25 different plant species into a footprint that small, isn't that just a recipe for absolute plant warfare?
Well, it is warfare, but not the kind you're probably thinking of.
Oh, because I'd assume they just choke each other out for resources.
You'd think so, yeah. But they aren't actually fighting for ground space. What's fascinating here is that they're forced into this desperate race for sunlight.
Oh, wow. So they just shoot straight up.
Exactly. Because they are packed so tightly, their natural behavior changes completely. Instead of spreading out their branches, they sprint vertically.
That's wild. So that extreme density is actually the secret weapon here.
It is. It's the engine of the Miyawaki method. They quickly form a high canopy, and meanwhile, that bottom layer of ferns and strawberries acts as a living mulch.
A living mulch. I like that. So it locks in the moisture.
Yeah, it locks in moisture and shades the dirt, basically acting as a modern-day cradle for the whole mini jungle.
Okay, but here's where it gets really interesting to me. To support that kind of rapid vertical sprint, wouldn't you need massive amounts of fertilizer?
You'd definitely assume that to keep 25 species fed in that small of a space. But actually, no, they don't rely on synthetic chemicals at all.
Wait, really? None?
None. The expert at the nursery, the man in the green shirt, he pivots their attention away from the plants completely. He tells them to look down at the dirt.
The underground engineering part.
Right. The real magic relies entirely on engineering the soil itself way before a single seed is planted. You have to figure out if the soil is rich in decaying organic matter, humus, or if it's heavy clay.
Yeah, he warns them that if the dirt is too compact, they have to bring in an earth auger to blend in straw and compost.
Exactly. He tells them they're aiming for a crumb structure.
A crumb structure. But what does that actually mean mechanically?
Well, think of it like baking a cake. If the soil is too dense, like heavy clay, it's basically a brick.
Right, and roots can't grow through a brick.
Exactly. They hit it and suffocate. But by augering in all that straw and compost, they are creating these tiny pockets of air and water, the crumbs.
Which lets the roots breathe and immediately sprint downward.
You got it. Though, very crucially, they do need to check for underground water pipes and cables before firing up that auger.
Oh yeah, definitely don't want to drill into a water main.
No, absolutely not. But if we connect this to the bigger picture, mimicking perfect native soil conditions right at the start is exactly why these forests work.
Because it lets them thrive without constant artificial maintenance later on.
Right. If you build that crumb structure so the roots can penetrate deeply and access water on their own, the soil does all the heavy lifting. The forest becomes self-sustaining.
It's amazing. So Kesser and Steen leave the nursery perfectly equipped. They've got the blueprint to gather seeds, map out their edges, and completely transform their neighborhood.
It's incredible, really. It proves how much immense ecological power can be packed into a tiny urban footprint.
Just by understanding how plants compete and how soil actually works.
Exactly. It really changes how you look at an empty lot.
It really does.
Yeah.
We know these tightly packed native trees are going to shoot up and create this rapid mini jungle above the surface, but it makes you think about what's going on down below.
Oh, absolutely. Completely out of sight.
Right, like What kind of unseen, complex microecosystems and intense root networks are quietly battling and cooperating below the surface in that freshly engineered soil?
It's a whole hidden world down there.
It is. The hawthorn might be the cradle above ground, but the true cradle is that vibrant, unseen world hiding right beneath our feet. Something for you to ponder next time you walk past an empty patch of dirt.